In this example, we have a system of two equations and we want to find the number of solutions of that system. This system is a system of nonlinear equations because neither of the equation is of the form ax plus by is equal c. A solution of such a system is a pair of numbers that substituted for x and y will make each equation true. So if we graph each equation in the coordinate plane, a solution of such system will be an intersection point of both graphs. When we work with the system of linear equation, we knew exactly how many solutions that system will have, either one or infinitely many, or no solutions at all. We cannot say that about systems of nonlinear equations because there is a lot of graphs that we might encounter when dealing with the nonlinear equations. So to determine how many solutions a system has, we'll graph each equation and check how many intersection points are there. In our example, the first equation is the equation 4x squared plus 9y squared equals 36. This equation has two variables, both of them are squared and the coefficients are positive. Therefore, this is an ellipse. We should be able to recognize the equation of the ellipse. If we write it in the standard form by dividing both sides by 36, we'll get x squared over 9 plus y squared over 4 is equal 1. And therefore, we can clearly say that the center of the ellipse is at the point 0, 0. To graph that ellipse, we need to find the x and y intercepts. We find the x-intercepts by looking at the number that is in the denominator of the x term. And we'll take plus or minus square root of that number, which will be in this case plus or minus 3, and these are the x-intercepts. The y-intercepts are found in a similar way by taking plus or minus square root of a number in the denominator of the y term. So in this case it's plus or minus 2. Once we have the intercepts, we are ready to graph the ellipse. So let's plot the points, the intercepts, and draw the oval shape of the ellipse. Okay, the second equation is the equation y squared is equal 4x. This equation has y squared and x in the first power, and therefore we recognize this as the equation of a parabola. This parabola has the vertex at the origin. This parabola also has the axis of symmetry, x-axis, because in the equation x is not squared, and therefore focus is on the x-axis. And to find the coordinate of the focus, I will have to solve the equation for coefficient of x is equal 4a, where a is the non-zero coordinate of the focus. So a is equal 1, and therefore focus is at the point 1, 0. So we'll graph the parabola using the vertex and the focus, and we know that distance between vertex and focus is 1, so we'll use latus rectum segment to graph that parabola. From the focus, we'll go 2 units up to find one endpoint and 2 units down to find the other endpoint of the latus rectum. And once we have those 2 points, we are ready to graph the parabola. This is the parabola with the equation y squared is equal 4x. Those 2 graphs clearly intersect at 2 points. One is in the first quadrant, one is symmetric in the fourth quadrant. Those 2 points are intersection of both 2 graphs, and therefore These 2 points are the solutions of our system. We cannot read the solution from the graph because the intersection is not on the grid lines, and therefore to find the intersection points we would have to use algebraic methods.